So if you recall, when we described the atom, we kind of thought of it as, remember, having a nucleus that has, I'll make these purple dots so that it's kind of hard to see, but I drew 1, 2, 3, 4, 5 purple dots. That's my protons. And then also inside the nucleus were my neutrons. And then somewhere outside of the nucleus, and remember they're so teeny tiny, but outside the nucleus were electrons. Now, they're not, remember, it's not like an M&M or it doesn't have membranes around it, but the electrons moving around create the volume. There's a lot of empty space in an atom. And so in the picture that we need to kind of understand is we know that protons and neutrons are in the nucleus all tight together, and the first illustration I gave at the beginning of this chapter was just the electrons are outside in electron clouds. Well, we need to understand what the electrons are doing just a little bit better than being in electron clouds. So we know that the protons and the electrons equal each other, so I know how many are out there, but I need to understand it just a little bit better. And the reason is, in the next 2 chapters, we're going to try to understand how the electrons are involved in bonding. And what that means is we're going to take atoms of different elements and put them together to form compounds. So we need to understand a little bit. Now this is actually kind of it's a theoretical, it's a mathematical model, and we're not really doing the math. So I always try to imagine this part when I'm trying to describe you as you go to the grocery store and you're going to pick up an apple. Now we know the apple had to come from a tree, and there's someone who took care of the tree. Maybe someone planted the tree, they watered the tree, they neutralized the tree. Like there's lots of pieces that go into getting that apple, but we just get the apple, like picking the fruit. And so I'm going to describe you like the general idea about how we might think about these things, but in the end, in order to understand what we need to understand for bonding, we're just going to be picking the fruit. So for this level of class, that's what we're going to be thinking about. So when we talk about electronic structure, what we know is that how the electrons are within an atom help us understand the different types of bonds that are formed and why certain elements like to form bonds, certain kinds of bonds with different elements. Now in the end, there's a word right here that I have in parentheses because we haven't discovered it yet, but in the end, it's the number of what we call valence electrons that will help us predict the types of bonds that form. And I'll give you a clue ahead of time. Valence simply means the electrons that are in the outermost areas of the atom. Okay, so here's a modern description. And remember, I'm not trying to get us to be quantum chemists. We're just trying to understand enough to get us to where we need for bonding. So in the box here, so a couple of things that we want to try to think about with electrons, and it's really kind of abstract, although in my mind I always kind of think of an illustration, even though it might not be exactly accurate. So it says, electrons do not move freely in space. Rather, an electron is confined to a specific region, giving it a particular energy. So electrons have particular energies. Okay, so they're going to have certain places that they are found. The other thing we need to consider is the second one. Electrons occupy discrete, or which I kind of think of as like individual or specific energy levels. Now, an important idea in the development of the theory of where electrons are is that the energy of electrons is quantized. So another way you see it, it says that is, energy is restricted to specific values. Now let me give you an example that I think is a perfect illustration of something that's quantized, and I did not make it up. So stairs are quantized. So if you think about walking up a stair, or stairway, in order, if you have your foot, right, you have to put your foot on a step. And I could put my foot, here's my leg, I could put my foot on this step, right? But if I put my foot up here above the second step, what is it going to do? It's just going to fall right back down to that step there. Because there's only certain places on the stairs that I can put my foot and still go up and down. Right? If I put it above it, it's just going to fall back down to the step. That's quantized because there's specific places you have to place your foot. I can even skip a step, but if I skip a step, I still have to put my foot on the one that, not the one that I skipped, but the next one up. Now, the opposite of being quantized, I don't know if opposite is the right word, but the other idea would be something that is continuous. And electrons, the energy of electrons is not continuous, right? Because if something's continuous, I can put my foot right here, I could put it here, I could take small steps, or I could put my foot way up here. It doesn't really even matter where I put my foot. I'm always going to land somewhere on the ramp. So I just can put it anywhere. There's nothing that I'm going to have to come back down to. I'm just walking. I can put my foot anywhere. And so when we think about electrons, what we're thinking about is that their energy is quantized, or it's restricted to specific values. And so we're going to learn how they label those specific values. So a big question then that comes up from this is, how do we describe where the electrons are found? And this is what we're going to try to figure out. So there's lots of different labeling, and I'm going to try to go as best I can through the labeling and then organize it. In the next video, we're going to take that labeling and try to organize it on the periodic table, which I think for you might be a way to put it all together. So at the end of this video, you don't feel like it's all quite coming together. Watch the next video and then see if it all starts coming together for you. Okay, so let's go through the labeling. So first they talk about what's called a principal energy level. So it's kind of like, this is like a floor. If I had a building, this would be the floor that you're on. Sometimes, and you see here I put shells, that's because depending on who's writing it or what textbook, sometimes instead of principal energy level, they'll say principal energy shell. Okay, so don't get, if it says level or shell, same thing. So the principal energy levels are the region where the electrons are confined. And when we number them, see right here, these are going to have numbers 1, 2, 3, whole numbers, 3, 4, 5, 6, 7, 8, 9. Well, I don't think it goes up to 9. Well, we don't do up to 9. But whole numbers, integers. And so in my imagination, this is again like a floor, like a building. So if I had a building, here's my building, then you'd have floors, right? So I could have the first floor, the second floor, the third floor, and the fourth floor. And this is kind of like an area, like if I'm on the first floor, that's kind of where, that would be one way I could describe where the electron is, kind of on what floor it is. So let's think, let's read these things and see how we kind of describe it. Okay, so the electrons closer to the nucleus are held more tightly and lower in energy. So the lower the number is, those are the ones closest to the nucleus. So N equal 1 is closer to the nucleus, so its electrons are held more tightly, and they would be considered lower in energy. Number 2, these numbers 1, 2, 3, 4 can be related to the periodic table, which is in the next video. Number 3, the farther the shell or energy level is from the nucleus, the larger its volume and the more electrons it can hold. So again, if you're thinking, and this is not how electrons are, but let's think of it as a circle instead of a rectangle there. So this would be level, let me change colors when I'm changing this. This would be level 1, 2, 3, 4. And you see that it's getting bigger, right? So 1 is only this big, but 3 is that big. So what this one here is saying, the bigger that number gets, 1, 2, 3, 4, the larger it is. And so since it's bigger, it can hold more electrons. Now we can calculate, although it's not necessary for this class, how many electrons will be in each level. If you square the number of the level you're on and then multiply it by 2, it would tell you how many electrons could fit into this level. So for example, what this is saying is if you're in level 1, if you said 1 squared times 2, that means level 1 can hold 2 electrons. Right? If you're in level 2, then you'd say 2 squared times 2. So 2 squared is 4 times 2. So level 2 can hold 8 electrons. All right, so that's what that is saying there, but it's not important that you memorize it. So before we turn the page, what I want you to consider is that one way we're going to describe where the electrons are is based on its principal energy level, and that's kind of like a floor. That's like the area that it could be. So if you were in on the second floor, that would be your energy level. It's kind of where you are confined at that moment. So then when we keep going, so we have a level, and then we have something called a sub-level. So sub means below, or I kind of think of it as within. So again, if I draw like a building, and I'm not drawing any windows or anything, just trying to get you to decide. Remember I said this is kind of theoretical, and we're not doing any of the math with it, so it's kind of weird. So if I draw a building like this, so each level, we have each level, and then they're divided. So each level is divided. Now I kind of think if I'm in a building, how's a building divided? It has rooms in it, right? So when you go into a floor, there's rooms. Okay, that's dividing that level. You don't, if we went into our campus, you wouldn't just see a big open floor, right? You go in and there's lots of rooms. So that's a dividing. So you can see the first dot says levels are divided into sublevels. So these right here are the levels, the principal levels, and then inside they're going to be divided. Now we call these divisions, these sublevels have letter names, S, P, D, and F. Okay, so each level, and I don't even know if why did I not, oh here it is, sorry. The number of sublevels is equal to the letter N, or the level you're on. So if this is N equals 1, it only has one sublevel. And we just call that S, because remember it's S, P, D, and F. If this is level 2, it's going to have 2 sublevels. They won't be equal, I'm just trying to show you. So this would be, if I had 2, I'd have an S and a P. If I'm in level 3, I'd have how many sublevels? 3. 1, 2, 3. So I have an S in here, I have a P in here, and I have a D. And then if I have 4, I have 4. So I have S, P, D, and F. Now for all the elements we know, we won't have to go past level F. So even if I went to N equals 5, even though it should have 5, it would still just have S, P, D, and F. Okay. Now, inside these sublevels, so these are the levels, these are the sublevels. Inside the sublevels, these contain what we call orbitals. Now, the orbitals have the same letters. Okay, so there's still S, P, D, and F. And depending on what sublevel you're in will depend on the orbitals. So let me, remember I told you, and I'm going to try to put it all together in this section too. So it contains the orbitals, and this tells you how many orbitals each thing contains right there. Now, how I imagine, so if I'm going with you, I'm trying to think with you how to best kind of divide this. So the levels are like a floor on the building. The sub-levels are like the room. And if you go in a room, there's chairs, right? Everybody's sitting on chairs. And the orbitals are kind of like the chairs. Okay, so if I go in, if I'm on the, if I'm right here in the S sublevel, well, there's going to be S orbitals inside of that, and those are the chairs. Now look, S only contains one orbital. As you go, P, anything that has a P over here on this, oh, darn it, sorry. Anything that has a P on this diagram, that would have 3 chairs in it. So let's just imagine, okay? S, and the shape of an S is a sphere, so I'll draw a sphere there. So all of, oh, darn it, all of these, my pen, it does not like it when I draw a circle. It thinks I'm trying to get something. Okay, let me make it a little fatter. Sorry for the delay. Okay, there's 1 and then 1. So anywhere, that's my S orbitals are a sphere, and there would only be 1 orbital in there, in the S. Okay, P orbitals, change color. P orbitals, if you look over here, it contains 3 of them. And P's look like dumbbells, so I'll put 1. They go in 3 different directions. It's hard for me to draw. So that would have 3. Oh, it's going to be a challenge. 1, 2, I can't draw them different directions. It's too hard. 3, and then 1, 2, 3. Okay. Now D, and this is going to get real hard for me because I don't think in the boxes I have, I can't draw them all. But D would have 5. 1, 2, they don't look like this. 3, 4, you can look in your book how the D's look. This would have 5. 1, 2, 3, 4, 5. And then the F, if you look over here, has 7. And if you are thinking mathematically, this would have 1, 2, 3, 4, 5, 6, 7. So if you look here, the D's and the S, you can look at Google online. The S's are spheres, the P's look like dumbbells, and then the D's and F's look a little bit different. I can't draw them in this little space. So, but that's how many chairs we have. And if you look at the pattern, so it's 1, 3, 5, 7. So it goes by odd numbers, right? So it's 1, 3, 5, and 7 orbitals. So let's fill out, or before I fill it out, let me kind of try to summarize it. So you have principal energy levels, and those are like the floor of a building. All right. Then inside those principal energy levels, you have sub-levels. Or they can be called subshells, but sub-levels. And these are kind of like rooms. Then they have like different things on them, numbers on them. And then inside the sub-levels, you have what are called orbitals. And those are kind of like chairs. Finally, we're getting to where the electrons will be. Now, all of this is going to be able to be related to the periodic table. So hopefully, after kind of thinking about this and then watching the next video, some of the pieces will start coming together for you. So when we get to the orbitals then, so if I go down here to the orbitals are actually like the chairs. This is where the electrons are most likely to be found. In the solution, in the modern solution of this, orbitals aren't really like chairs. It's just it's an area, a region of high probability of finding the electron. So that's where we're most likely to find that particular electron or electrons. And each orbital, this is important, you see it's underlined here, can hold 2 electrons. So let's try to go through this picture and see if we can kind of put a little bit of this together already. And I know it's challenging. I know this is challenging. And it's all theoretical. I want you to kind of ponder on it. And in the next video, we will put it back to the back onto the, the periodic table. Lost my thought there for a second. Okay, so on the level 1, so I'm looking over here on this picture. Okay, so in level 1, there is only one kind of orbital there, because anytime you are in an S sublevel, there's only one orbital, and so we call it a 1s. Now the 1 doesn't mean they're 1. The 1 tells me the floor I'm on, or the level I'm in, right? Because look here, on 2 there's also an S. So if I just say S, you won't know what level it's on. I have to say 1s, and then you know it's on level 1. Now, in S's, if you look up here, only have one orbital. That's why I only drew one dot. And each orbital can hold 2 electrons. So on this first level, all I can have are 2 electrons. Now, the second level, if I look here, so here I have a 2s, and I have a 2p. And we also have the 2p. So that, let's see, S's have 2 electrons, remember, because there's one orbital, and P's have 3, which means they have 6 electrons. So that is 8 electrons, because it's 2 for the S's, and P's have 3 orbitals, so they're going to have 6. Then we go to the third level. We have a 3s, a 3p, and a 3d. So S's have 2 electrons. I'll write it out this way. So they have 2 electrons, S's do. All of P's, they have 3 orbitals, so they have 6 electrons. And the D has 5 orbitals, so that is 10 electrons. So we get 18 electrons. See how it's getting more and more? And then you go to the fourth, and we have 4s, 4p, 4d, 4f. And we have 4s, 4p, 4d, and 4f. And so we have 2 in the s's, plus 6 in the p's, plus 10 in the d's. And I'm getting 10 because d orbitals have 5, d levels have 5, and then F sublevels have 7, which would be 14. So that is 32 electrons. So the first level has 2, the second level has 8, the third level has 18, and the fourth level has 32. And anything past the fourth level will also have 32 because we only have, the most we have are S, P, D, and F sublevels. Now, let's see if we can figure out a few things. So if the question is how many electrons, okay, on each one of these. So if you have a 2p orbital, how many electrons fit in here? Well, let's look back. So if we look here, each orbital can hold 2 electrons. So any orbital, no matter what it has in front of it, can only hold 2 electrons. A 4f orbital, 2 electrons. A 3d orbital, 2 electrons. A 1s orbital, 2 electrons. Any orbital only holds 2. Right? So in my picture, an orbital would just be one of these things, or one of these things, or one of these things. It can only hold 2. Whoops, sorry. Now, what if it said the 3D sublevel? Okay, so a sublevel is like the room. So the key here is actually not the level here, but the letter. Okay, so go back. So a sublevel is what's ever in one of these blocks. So here's the sublevels, and it tells us how many orbitals are in it. So if a D sublevel, no matter where it is, it doesn't start till the third level, but either in a 3D or a 4D or a 5D, if it's a sublevel, it has 5 orbitals. Okay, so the sublevel, if it's a D sublevel, it has 5 orbitals. We have 2 electrons in each orbital, so that is 10 electrons. Okay, so now I see, I'm looking at one of the problems in your book. And then it says, then it goes 3D orbital. Okay, they're trying to trick you now. Remember, if it's just one orbital, how many electrons? Just 2. Like this doesn't matter because it's an orbital. Well, what if it said a 4p sublevel? Okay, so sublevels are all the orbitals in that section. So it doesn't really matter even that it's 4. What I'm looking at is p's. So I look back here and a p sublevel has 3 orbitals. So I have 3 orbitals in a p. Anything that's a p, I have 3 orbitals. And there's 2 electrons in each. So that means a 3p would have 6 electrons. Now, what if it asks for the third, whoops, if I could spell third, embarrassing, third, it could be the third energy level, or it could be the third shell. Remember, sometimes they call it shell. Okay, so I'm getting a little further down. The third shell, so if they're talking about a whole energy level or shell, then coming up here, they're talking about everything that's on that level, or my picture, which is getting kind of a mess. Everything that's there. So the third level, remember, each level has that many subshells. So the third level would have 3 subshells. So it contains a 3s, a 3p, a 3d. Well, I know that s's have 2 electrons, p's have 6 electrons, and d's have 10 electrons. So if I add that all up, the third level would have 18 electrons. Now this, again, is not an easy thing for most people. So if you feel a little confused right now, that's okay. Practice it, concentrate, see what kind of questions you have. And then in the next video, we're going to relate all this SPDF stuff and all the 1, 2, 3s to the periodic table.